Please subscribe to Likhitha H YouTube channel and press the bell icon to get early notifications on my latest YouTube video updates. What's up folks, welcome back to my YouTube channel Code to Create. In today's video we're going to classify the types of raisins. So raisins are types of dates but they're pretty different from dates. Let's first see our data set. We're going to read our data set. Before that we have to import pandas as usual. I'm going to import numpy. And after that, I'm going to read our dataset. I'm going to name this dataset as df. So I'm going to say df is equal to pt.read underscore csv. It's in the form of CSV or Excel. That's that thing also we're supposed to see. Yes, guys, after reading the dataset. Okay, let's try it in Excel. Yes. Now let's see our data set. We have the total area of the raisin. We have the major axis length, that's vertically the length of it. And we have the minor axis length, that's the horizontal length of it. And the eccentricity, how diverted is it from the center. And then we have the convex area, how bulged the raisin is, to which extent the perimeter of it, and then at the end our class. So there are two types of raisins, one is Kesselman and the other one is Wesley. Now we're going to check some information about it. So I'm going to say df.info. We can see the data type, the null count and everything. How much, you can also see how much memory it uses, And now let's see the correlation between them. I'm going to import cbond for that. I'm going to import both cbond and matplotlib. I'm going to say import cbond as SNS and import matplotlib dot pyplot as plt. And after this I'm going to say sns dot heatmap df dot core, that's for correlation, and annotation is equal to true. Let's run this. Yes, we have our correlation heat map. And after this, let's take their class count. So I'm going to say df dot class dot value counts. Yeah, we can see we have Wesley 450 and Kesselman. Both of them we have 450. Now I'm going to plot all these features into a box plot. Let's do that. I'm going to say ax is equal to plt dot subplot. Let's set its size. I'm going to say figure dot set underscore size underscore inches. We're going to set it to 18 and 12. This is all about the box plot only. So now what I'm going to do, I'm going to say features is equal to df dot columns dot toList, and then I'm going to say features dot remove. We're going to remove class. We're going to remove class and the convex area, because it's almost the same thing as the area itself, but just how bulged it is. So I don't think it's needed. So I'm going to remove this. And then I'm going to say for axis comma feature in zip x comma features. sns dot box plot to feature nax is equal to axis, and then I'm going to say axis comma set title as feature, whatever the feature it is defined. Okay, this must be a mistake. Oh yes, feature is not defined. Okay, that's features S. Let's run this now. Yes, we have our box plot here. All of them we can see. And now let's see the scatter plot of this. The whole data, let's just see the scatter plot of it. So we're gonna do the same thing we did. We're gonna add a new variable type over here. That's the inspect pairs. We're gonna check how correlated are these. Like, we're just gonna plot them into a scatter plot and check. We're gonna do that for extent and eccentricity. We're gonna do that for major axis length. Okay. And minor axis length. And for perimeter and area, I guess it's P capital. The 1 minute. Yes, for perimeter and area, and for the eccentricity and perimeter. Now what we're gonna do is come down. We're gonna say for axis comma pair in zip inspect pairs. Which one is the x-axis and y-axis? We're gonna get it from the pair. And then we're gonna plot this up. We're gonna say sns.scatterplot data STF x is equal to x feet, y is equal to y feet, based on the class x is equal to axis, alpha is equal to 0.6. Another error. Subplot takes 1 or 3 positional arguments, but 2 are given. Not 3 positional arguments. So Okay, we have to make this as subplots, and made it as subplot. Yes, you can see it now. We have it. We have the eccentricity, the extent, we have minor and major axis length, we have perimeter and area, and also we have perimeter and eccentricity. And all these are based on the class. Now after this, let's get all the values of this df. So I'm gonna save this thing in a data set. So I'm gonna say data set is equal to df dot values. We're gonna do this to convert our data set into an array. Let me show you guys. Yes, you have your array now. And then we divide our data set into x and y. So we're gonna say x is equal to, we've got all till our 7 from 0 till 7, and 7 is excluded. So it's basically the whole data set other than the class. Let me show you guys x. Let's just make it as small. We got it. And then let's divide our data set into y. So I'm going to say y is equal to df of class, this C capital, yes, class dot apply lambda. So lambda is basically like a small function. Let's see. If it's Casimir, it's 1, or else, wait a minute, yes, else 0. Let's just make it as bigger one, that's better. Yes. And then we're going to convert to numpy. Let's run this. Let me show you guys our y value. Yes. Yes, we have a whole array. You can see it's either 0. Okay, there has to be ones also. Don't find any mistake. What's the problem? I don't find any problem. I don't know why it just keeps showing 0 here. Did we put the capital K? Yes, sorry guys. And now let's import the pre-processing. So I'm going to say from sklearn import pre-processing. And then I'm going to say min-max scalar is equal to pre-processing dot min-max scalar. We're going to get it from the pre-processing itself. So I'm going to say, and after this I'm going to say x scale is equal to min-max scalar dot fit transform x. Let's see the x scale now. Yes, we have that array. And after this we're going to split our data set. So I'm going to say from sklearn dot model selection import train test split. And then I'm going to say x train comma x val and value and test both y train y and test. You can name it anything actually, it's not a problem, but in the same order. And then I'm going to say train test split split x scale comma y comma test size, let's set it as 0.3. Let's run this. Yes, now let's say x value comma x underscore test comma y value comma y underscore test is equal to train test split. And now what we're going to split is the x underscore value, this one, so underscore value and test. I'm going to do the same to y underscore value underscore and underscore test, and let's set the test size to 0.5. Let's run this. Yes, now let me show you guys the x train. Yes, let's see the y train. We have our data. Now let's import the sequential, tens, dropout and the regularizers. I'm going to say from keras.models import sequential, and S should be capital, sequential, and then I'm going to say from keras.layers import tens and dropout, T capital, and then again I'm going to say from keras import regularizers. Let's run. It says an error. Okay, that's sequential. Yes, it's done. And after this, let's create our model. I'm going to say model is equal to sequential the tens, their layer, everything we're going to set, their activation, and the kernel regularizer sir is equal to regularizers. Input underscore shape is 7, and let's say dropout is 0.2. Let's just copy the same and change the values. This it's 64. We don't need the input shape because we have already given it. Yes. Dropout at 0.2. Then we don't need the dropouts after this. The dense 37. And then 10. All of them don't need thing. Yes, and the last time, let's put the tens, and let's set it to 10 this time, and let's change the activation also. Let's change it to sigmoid. We don't need the input shape again. Yes, let's run this now. It says an error. Oh, sorry. It's activation. Let's run this. Dropout not defined. It is defined. Oh. Okay, let's try it with T capital. That's the mistake. Wait. Yes. And after this, let's just say model dot compile. Let's run this. Let's set the optimizer to Adam and the loss to binary cross entropy. And the metrics to accuracy. Run this. And then let's import early stopping and model checkpoint. I'm gonna show you guys why. Dot callbacks import early stopping and model checkpoint. Let's create a class for it. Let's just say yes is early stopping, because we can't keep calling it always, so I'm gonna say yes as that, and the monitor as accuracy, the mode to max, and the model checkpoint also. Let's do the same. Let's say model checkpoint as model H5, and the monitor to accuracy, mode to max. Let's run this. Yes. And then I'm gonna say hist is equal to model dot fit x train comma y train, and let's set the batch size to 32, 150, and validation data is equal to x value come by in callbacks, time of any callbacks. Let's put it as both of them, early stopping and model checkpoint. Let's run this. It says an error. Oh, I don't find any problem. I don't get it. We have saved it like that only. Saved it at x value and let's check. Yes. And they are of the same shape, I'm sure. I don't know what's the problem. Let's try running it again. Okay, guys, we had to make it 1 and we made it 10. And I don't think, let's make it as 32. Let's try rerunning it again. Yes, that was the problem. Yes, it stopped. There's early stopping over here. Now let's evaluate this x test and y test. So let's just say model dot evaluate x test and y test. Once. Yes. And now let's compare this up. Let's just see the model loss of it. I'm gonna import matplotlib for this. I guess it's already imported. Yes, it's imported. So let's just directly go there. We'll say plt.plot history loss. And then I'm going to say plt.plot the value loss. And then let's set the title. Dot title. Let's just set it as model loss. plt.y label is loss. p.x label this is the train and the value data, right? Yes. Let's print all of this. Let the labels and all stay at the upper right. That's what I'm saying. Now let's see the data set. Now let's see the plot. Yes, you can see, we can see the train and the actual value and what is the loss of it. So this whole plot is basically about the model loss. How much does the train value and the actual value differ? And now let's just see the accuracy and end this up. So I'm going to say plt.plot. I'm going to say plt.plot history. Then accuracy. Then again the same thing, plt.plot history. Their value accuracy. And then the label t dot their title and label both. So I'm going to do the title first. Model accuracy plt.y label as accuracy and the x label as epoch. X label and then of the train value and the actual value. And this one, let's just put it in the lower. Okay, let's just say log is equal to lower right. Now let's see our plot. The accuracy is pretty good between the train value and the actual value. So guys, now we know how to differentiate between the Besney and the Kesselman using data science. That's great. Thank you guys. Please do like, share and subscribe. Bye bye.